Everybody. My name is Ethan Lilly, and today I'm going to walk you through how we at Topgolf transformed our game platform from a Windows VDI-based solution to a Linux and Kubernetes-based platform. First, let's go through our agenda. I'm going to kick things off with a quick intro into who I am and who Topgolf is. Then I'll jump over to what the problem was we were facing, then how we came to our idea of moving to a Kubernetes-based platform, and then finally, I'll go over the solution that we came up with in full detail and show some pictures of what the final product looked like. Then I'll go over some lessons learned as we went through this process, and then I can cover what we're going to go into next. All right, now for a quick intro into who I am and who Topgolf is. I started out back at Raytheon as a software engineer, but quickly pivoted into an infrastructure engineering role. There I worked on OpenStack private cloud. I worked on AWS GovCloud, as well as some bare metal PXE-booted Kubernetes solutions, which kind of pivots into what we did here recently at Topgolf. At Topgolf, I started out as the lead release engineer, and that role has kind of changed over the years. We pivoted from release engineering to DevOps, and now we call ourselves platform engineering. As I'm sure a lot of you are familiar with, our team wears a lot of hats. But here are some of the tools and expertise that our team has. We're very big on Kubernetes. We try to use that as much as possible. We use Terraform for standing up all of our infrastructure. We use Ansible for configuring all of our infrastructure. And we use Jenkins for our build pipeline as well as deployments. We try to stick with Linux as much as possible. And we're very big fans of Python. We use it heavily for a lot of our scripting. So what is Topgolf? Some of you may have never been to a Topgolf before, but all it is a mix of a high-tech driving range and a full-service restaurant and bar. There's a lot of technology behind the scenes at Topgolf, from the pre-visits online with reservations to the front desk getting you into a bay, to the in-bay gaming experience itself, and then as well as the food and beverage operations. There's a lot of technology behind that. We have a small server room at each venue to help drive all of these backend services required to make this technology work. We like to run our critical services on-prem to keep the venues operating in case of a power outage or an internet outage. And each venue has a Kubernetes cluster that we deploy most of these services onto. So what is in a bay at Topgolf? Let's take a deeper dive into each aspect of it and the different components. So on the left, on the bottom, you'll see what we call our touch panel or our game panel. It's a small 4x3 screen, and unfortunately, our vendor doesn't really support it anymore, so it costs a lot for what it is. It doesn't have a built-in GPU, so we can't really run games on it. And it's also running an old Ubuntu 16 image with a Chromium browser and kiosk mode. On the top left, you'll see what we call our bay board or our table-facing screen. On the top section there's a TV feed that you can change the channel on from the game panel. In the middle, you'll see what we call our game screen. That is where the Unity game itself runs. And whenever a game isn't running, we show this 1, 2, 3 screen to help people know how to get into the system and start a game up. On the bottom is an actual extension from the touch screen itself. It's driven by the touch panel, and it's just another Chrome window with some information on it and some ads running. On the right side, you'll see our new designed dispenser with the TV built into it. The TV just mirrors the game screen from the left side on the bay board. So anytime you have a game running, that helps the player be able to see that game right in front of them as they're hitting the ball. All right, now let's get into the problem that we were trying to solve. Before we get too far into the problem itself, let's take a look at our original architecture a little bit more. This view is a greatly simplified version of the original architecture, but it shows the key components. When a player selects to start a game, like Angry Birds, on our touchscreen, a RabbitMQ message is sent from the Chrome browser to the launcher that's running on our Windows Horizon VM. Launcher is just a simple Unity application that displays normally the 1, 2, 3 screen that you saw before. But when it receives a message to start a game, it will actually launch that game locally, and that game will launch and take over the full screen and display on the TV. Whenever we want to deploy new versions of our games, we have a Jenkins job that builds a new snapshot of this Windows desktop image with those new games installed. So here's the problem. Our game deployment is too expensive. Touchscreens that we're using today are outdated and way too expensive. The VxRail Horizon Windows licensing and infrastructure costs are way too high. The deployment pipeline is slow and cumbersome and requires a lot of attention. Huge effort is put into re-imaging these touchscreens. Anytime we want to roll out a new image for the touchscreens themselves, we have to have somebody on site with a USB drive go to every single touchscreen. That's 100 plus touchscreens at every venue, so that's a lot of work to be done. Most importantly of all, we have to write automation for Windows desktops, which we all know is just the worst. All right, now I'm going to cover how we came to the idea of running on Kubernetes. Little background here. This project was started as a way for us to get together with our friends in Sweden and TopTracer and come up with a way to create common architectures to solve problems. We called it One Topgolf. The original idea was focused only on replacing the touchscreen with the much better and cheaper model that they use at TopTracer ranges. But when reviewing how they run their games on the touch panels themselves instead of on some expensive backend hardware, we thought, why don't we do that? Then they started talking us through their current custom Docker orchestration services they have. And we said, why not just run it on Kubernetes? Of course, everything is better on Kubernetes, so that's what we did. The TopTracer team had experience running Unity games on Linux inside of Docker containers, which my team was a little skeptical of. My team had the experience of managing many Kubernetes clusters with lots of microservices, which their team was still learning. The new game panels had everything we needed to run the games, with plenty of CPU and memory, and most importantly, built-in GPUs. So together, with those three things, we had all the pieces of the puzzle needed to make it happen. All right, so now let's talk about what was the final solution. What did it look like? First, let's take a look at our architecture. The touchscreens are now PXE-booted with a custom image that has baked-in startup scripts for configuring things like the VNC sessions required to share the screens, as well as some scripting to join itself to our Kubernetes cluster. Once it's joined to Kubernetes, due to the labels that we've added to it, it will automatically get scheduled a Chromium pod for running on the touchscreen and the bayboard, as well as a launcher pod to display the 123 screen on the game TV. When a player selects to start a game of Angry Birds, instead of the launcher on the touch panel actually starting the game, a new service we created called Kate's Game Launcher will spin up a pod via the Kubernetes API on the touchscreen for that game. Now, when we want to roll out updates to our games, it's a simple Helm chart deployment through Jenkins, no longer having to do a rebuild of a Windows desktop image. Here's a quick look at what the final product looks like in action. Here you can see the three different screens on the top of our new touchscreens. Previously, our old touchscreens just had the two on the left with the Chrome browser on the left side and then another Chrome window in the middle showing our ads as well as some leaderboard statistics. Now with the new touchscreen, you also can see a third screen on the right showing our launcher application running. So with these three, now we can drive all the TVs we need from just one piece of hardware instead of having to rely on our backend servers. On the bottom is a screenshot from Rancher showing the different pods running on this game panel. There's an observe pod with a FluentBit application running for shipping logs and metrics. The Docker Touch Panel pod runs both the left and the middle screen that you see above as Chromium browser windows. And then a Kubernetes Game Launcher Cache Warmer pod that pre-downloads all of our Docker images needed to run the games so that they launch instantly when a player selects a game to play. And finally, the launcher pod, which is now driving that 123 screen on the right side that you see. This shows one of our test labs where we initially set up our development and testing. You can see how the three screens are spread across the various TVs that make up what goes into one of our Topgolf bays. On the bottom, you can see the touch panel there with the Chrome browser up. On the TV on the top right, you can see in the bottom the other Chrome window that the touch panel drives. And then you can also see mirrored across the two TVs, the 123 launcher screen, now all driven by just the one touch panel. And finally, this view shows what it looks like when we're running a game. I do not have a screenshot from Rancher showing the pods, but if I did, you would see one extra Angry Birds pod running, which is what you see on the far right side. The far left side is still our Chrome browser. It's just a new view for the player to interact with, to change settings in the game, and to move between players. So did this solve our problem? Yes, now our touchscreens are modern and cheap. No more VxRail Horizon licensing, no more Windows licensing. Deployment pipelines are now fast and simple. It's just like any other microservice deployment with Helm through Jenkins. No effort is required to re-image the touchscreens. You simply reboot them and just let PXE do all the rest. And most importantly, no more Windows. Everything is now running on Linux. And bonus, game panels are now more resilient. They're running on Kubernetes with self-healing Chrome browsers and launcher pods. We get a lot more observability for free because of how our Kubernetes clusters are configured. Games now run much smoother on the local GPUs instead of having to stream from the Horizon VM. Now everything's running locally. And we have a ton of new horsepower added to our Kubernetes clusters. So in the future, potentially we could reduce the size of our server rooms and run more workloads on the game panels themselves. Now let's get into some of our lessons learned as we went throughout this project. In order to speed up the launch times when a player selects to start a game, we pre-download all of the Docker game images to all of the touch panels in the venue. Some of the venues don't have a very large pipe going out to the internet, so when deploying an updated game image, it could take a long time to download them all, if ever. We had to add a Docker registry proxy that the game panels could use locally to cache the image layers as they download. That way, all the touch panels can download over the LAN instead of having to go out to the internet. During initial development of our custom PXE image, it could be problematic at times to try and troubleshoot what was happening in the init RAM disk. So we added an OTel collector to ship our logs during the RAM disk phase to our central logging platform Observe, so we could better see what was happening. We had some debate on when to reboot versus re-image the touch panels as issues came up. We ended up landing on a 3 R's approach for our support team. First, reboot it. If that doesn't fix the problem, re-image it. And if that still doesn't fix the problem, replace it. Some of our games initially had some funny artifacts appearing when running them on the new hardware. After a lot of trial and error, we discovered that we needed the right mix of new graphics drivers to get the games running smoothly. Also, some of our venues have some pretty old cabling for our HDMI cables. And unfortunately, that caused us to have to replace a lot of them. And some of them were not easy to replace, but thankfully our install team is an excellent crew and they did a great job of working through the problem so far. So what's next for Topgolf? We have this new setup operating in 5 venues so far, and it's working great. Now we need to get it rolled out to the rest of them. We are going to work with our Sweden team with TopTracer to help get them running Kubernetes on their ranges as well. That way we can continue to find ways to have common components shared across the 2 teams. Some of us, mostly me, would like to explore shrinking the footprint of our server room by running some of the workloads on the game panels themselves. There is now a ton of extra resources on our Kubernetes cluster, so I think we should be able to use it. I would also like to explore other opportunities to add more edge devices to our Kubernetes cluster for easier management and deployments. And that's it for the presentation today. Thanks for listening, and I hope to see you all at a Topgolf soon.